All right, so we can go ahead and get started. Good morning, everyone, and thank you so much for joining us. Um, we're really excited today since this is our first webinar hosted for our first T-Rex Classroom series here at Rexgear. So I will be your host today. My name is Afreen. I'm the sales engineer for the East region here at Rexgear. I'll be excited to introduce Rouiela Valencia, who's our West Coast sales engineer here at Rexgear. So Ro has a background in physics from UCI, and she brings a good blend of theoretical knowledge and hands-on experience supporting testing across various power electronics applications. So today's presentation is called From the Lab to the Moon, and this will focus on how rover systems can be tested and validated using Rexgear and iTech's bidirectional power supplies and solar array simulators. So in today's presentation, Ro will walk us through both customer-facing and in-house test configurations, showing how we can replicate real-life mission scenarios here on Earth before deployment. This includes simulating solar panel behavior and managing dynamic charging and discharging. Ro can also highlight some of our key test scenarios that we have with our products, such as constant voltage, constant current control, our dynamic load profiles, and how our tools like solar array simulation software and battery simulation software can help you guys to validate your performance and reliability before deployment. So this is useful whether you're working on space applications, EV applications, or batteries, since the concepts are very transferable. So hopefully by the end of the session, you'll have a clearer understanding of how to build flexible environments that can mirror real-world operating conditions using Rexgear and iTech. One thing to note is that this meeting will be recorded, so the meeting will be shared with you at the end. So I'm going to go ahead and present Ro. And we will also be taking questions, so please feel free to drop your questions in the chat. And at the end of the presentation, we'll have a Q&A where we can answer your questions.
Hi everyone, welcome to T-Rex Classroom. Thank you all so much for joining me here today for the first webinar of this amazing series. My name is Rouiela Valencia. I'm the sales engineer for the West Coast region, and this is my presentation on rover performance tests for varying irradiance and dynamic loading. So this is the outline of the presentation. This is going to start off with the background and application, then equipment selection and system architecture, then followed up with the test methodology and results, and finally, the conclusion. Starting with a background and application, this is essentially a lunar rover mission to the moon, which is, by the way, perfect timing with the recent Artemis 2 launch. And this is to investigate the lunar polar volatiles, primarily water ice, but it can be carbon dioxide or ammonia. This is located at the moon's permanently shadowed regions, or PSR for short, and with successful operation and results, this can open the opportunity for human lunar colonization. The rover uses two ways to power itself. So it uses a solar array as its primary power source, and it also has a lithium-ion battery pack for it to use when it goes into the permanently shadowed region where there is little to no sunlight at all. A project like this poses two questions during testing. The first one is, what is the rover behavior as solar irradiance changes? And irradiance is essentially just how much sunlight there is at the time. And two, how will the rover behave during full battery operation in the PSR under dynamic loading demands? Before I talk about the equipment selection and justification, I just wanted to give a brief overview of the system architecture itself. So I have the solar array connect with the DUT as the rover and then the battery itself. So for the DUT, I did a generalized case because realistically, inside the rover itself, there is something called a power conditioning and distribution unit. So inside this, it has a regulated power distributor, battery charge regulator, and the MPPT, just to name a few. So this PCDU essentially just acts as a bridge between the solar array and the battery itself. To delve a little bit more into detail, so as I said, the PCDU is a rover subsystem that regulates and distributes electrical power throughout all of the rover's electrical components. The important thing for this application is the MPPT, which is the maximum power point tracker. It's a component inside the PCDU that continuously optimizes the operating point of the solar array as the radiance changes to ensure maximum power. As I mentioned before in the previous slide, the PCDU essentially acts as a bridge between the solar array and the battery, but in this presentation, I just did a generalized case with the rover itself. Now with equipment selection and justification, this is going to be a 60-day operation. And essentially for the rover itself, it just needs a requirement of maximum operating power of 460 watts. And this 460 watts is in the instance of if everything is powered on at the same time, but obviously that won't be the case. This requirement will differ depending on its demand. And I will go into detail into that in the following slides as we go along in the presentation. Next, we have our solar array. So you can see in the table here, our requirements for this is that its voltage at open circuit is going to be 2.726. Its short circuit current density, 16.5. And then its voltage at maximum power, it's 2.41. And then current density at maximum power is 16.5. In this configuration, we have 13 in series and 15 in parallel. So I did the calculations. So our new parameters are going to be for VMP, that's going to be 31.3 volts, VOC 35.4. The IMP per cell is going to be 0.98 amps per string. And then the IMP for the array itself is going to be 14.9 amps. Battery itself, pretty self-explanatory. The max voltage is going to be 29.4. Voltage at empty, it's going to be 22 volts, and its capacity is 29.43 amp hours, and its current 16, with its power being 800 watts. So with the solar array, to emulate this, I chose the ITN2121 with the solar array software. Utilizing this equipment would remove the constraint of having to physically wait for the sun to portray a dynamic irradiance. Projects like these are very limited on time, so having this sort of software eliminates that obstacle and saves you so much time instead of having to wait for hours or even days or weeks for a certain irradiance level to come by. So with the ITN2121, its parameters are pretty much in range of the solar array itself. So it has a maximum voltage of 80 volts, current of 25 amps, and a power of 800 watts. And as you see here, the solar array only needs 31.3 volts, 14.9 amps, and a power of 466. So it's perfect to be used as the solar array emulator. So the key features for the ITN2100 is a high performance DC power supply. It has an ultra low current ripple with high precision sampling, programming, and measurement, which is very much so ideal in testing like this. And it also has a real-time data and curve recording. And again, very ideal for when you want to do a test like this. So this includes a specialized SAS 1000 software. And you're probably wondering, why do I need it if the ITN2121 already has that? Well, the ITN2121 has 5 built-in PV modes, but it's pre-configured. So you have no freedom to edit it. The SAS 1000 software has a customizable IV curve, so you can emulate a varying IV curve as much as you want, a dynamic one, and it also has a shadow emulation and vendors with solar array specs that you can use for when you're doing testing. If it's not available for the certain solar array that you have in mind, you can honestly make your own tab and then edit it yourself, and it'll save there in that program. It can also do MPP testing for up to 250 hertz. So just like with the solar array, the same reasoning goes for why we need the ITM3432 for battery emulating. This saves up a whole lot of time by not needing to physically wait the discharge and charging of the battery itself. So this is really ideal for time-sensitive projects such as this. So as you can see, the ITM3432 ranges are in line with the lithium-ion battery. So the voltage is going to be at 60 volts, the current 30 amps, and the power of 800 watts. While the lithium-ion battery is 29.4 to 22 volts, 15 to 16 amps, and the power is at 800 watts. So this is perfect to emulate the lithium-ion battery. The key features for the ITM3432, it is a bidirectional DC power supply. It's also a 1U half rack, so it's super compact and it saves up so much on space. And it also has a seamless switching between sourcing and syncing, which avoids voltage and current overshoot. This is really ideal in battery testing because if that ever happens, this would damage or strain the battery. I also use the battery simulation software. This is our specialized software, the BSS 2000. So just like with the solar array, the ITN2100, the ITM3432 does come with battery emulation, but it is a linear curve, meaning that it does not emulate the different battery chemistries. With the BSS 2000 software, you can do that. And one of the compositions is the lithium ion, which is what I needed for this project. So I was able to accurately portray the charging and discharging behavior during this test. Right, in this slide, I'll go ahead and explain the sort of setup that we would use for testing. So for the customer testing, it's pretty much straightforward. You just set up the ITM21 CV mode with SCS connected to DUT itself. Same goes for the ITM3432 in CC mode with the BSS2000 software and connecting it to the DUT as well. For the in-house testing, I had sort of limited equipment at that time because my team went to 2 shows last month, the battery show and the Apex show. So I really hope that you guys were able to stop by and check out our booths while you were there. So back to the in-house testing, I used the IT66000C. This is our bidirectional unit here. And it is 42 kilowatts in 3U. So this is the highest power density right now in the market. And the fun thing about this is that it's actually dual channel. So as you can see on the images here, that I use a single unit for all of my testing. I use it as my solar array, I use it as my DUT, and I use it for my battery. So it was pretty cool because I just set up one channel as either the solar array or the battery itself, and then the second channel stayed as the DUT. So just to delve into a little bit more detail, yeah, the one channel was CV mode with the SAS, and the second channel was for charging when doing the battery. It was in CC dynamic current list, and then for discharging it's a dynamic load list, which I'll get into detail later. And again, for the battery itself, CC mode with the BSS 2000. Right. So just circling back to the original questions that I had in the beginning. So we have 2 questions during testing. So test A is going to be, what is the rover behavior as solar radiance changes? And then test B, how will the rover behave during full battery operation in PSR under dynamic loading demands? So from this point onward, I'm going to go into a little bit more detail of the in-house testing, since the customer testing is pretty straightforward. And in the in-house, it had a little bit more configurations and setting up. So I'm going to explain that a little bit more. So starting off with test A, this is my setup with channel 1 being CV mode with a solar array simulator, and then test 2 being with channel 2 being the CC load mode. Then this will emulate our rover. The communication that I used was via LAN communication, so I just used my laptop. And then with the SA software, I manually set the shadows to customize the IV curve so I can emulate the rover travel from a sunny region to the PSR. So as you can see in the image here, that this is the curve that I use, and this is the shadow emulation that I also use to get this curve. So pretty customizable, very cool. So for channel 2, because I physically don't have the MPPT itself, and we unfortunately don't have a Rexgear rover, so I had to manually adjust the current value to optimize the MPPT efficiency. In other words, I acted as the MPPT itself during the testing. So these are the results. So for the MPPT efficiency, I was honestly very well. The MPPT achieved 99% efficiency even as irradiance changes. And as you can see here, it's going to start changing and changing as this shadow moves. This is the shadow emulation that I mentioned before. And as you can see, as I change the current, these little 2 dots find the optimized point, even as the curve differs during time. So as you can see here, also in this video, is how I set up the solar array software I had. And then for the PV module, I had it set for serial in 13 and parallel in 8 because that was the maximum that I was able to set. But even then, regardless of what values I set, the behavior would be the same. So on the left-hand side, we see that the average voltage was 26.4, maximum was 32.4, minimum 20.441, and then the average MPPT was 99%. So honestly, pretty well, because I acted as the MPPT itself, so it got pretty close. Right, now for test B, this is going to be our battery. So the setup was channel 1, the BSS 2000, channel 2, CC load mode for the rover itself. And again, I used LAN communication. For the BSS 2000 specialized software, I have 2 photos here to show. For the left-hand side, this is going to be the customer testing. So this is where I set the real battery values, and if you're going to emulate this in real life. And then on the right-hand side, this is going to be my in-house testing. And because due to time limitations, and obviously I cannot stay in office for 60 days straight discharging a battery, I set differing values to expedite the testing process. But regardless, again, the battery behavior between the 2 tests will essentially be the same. So starting with its charging mode, so I made something called a dynamic current list. So this was a list function that was utilized to emulate the dynamic sourcing of the solar array to the MPPT and to the battery. So this essentially is emulates how battery is charged after the MPPT optimizes power values as irradiance changes. So the results that I got from test A, that is what I used for this test. So as you can see for this column right here, these were the current values that I received from test A, and I told it to do 6.9 amps for 25 seconds, 7.21 for 15, and so on, just to emulate that. So these were essentially the results. We can see that there is a proportional relationship between the current and SOC. So the SAS current represents the MPPT operating points for the optimal solar power extraction. So as you can see here, when the current is high, we can see a little bit of a sharper slope. And then when it's not so high, a little bit slower. And I know it is very hard to see right now, but there is a behavior there. And I believe in it so much that I dedicated an entire slide just to show you guys. So yeah, as I see here, so higher current demands, steeper slope, not so high, not as much, and then so on and so on and so on. And honestly, it's very hard to see, but this really just shows that the MPPT efficiency was really good, that even with the different current values, we can observe a near linear SOC rate. And now we have the discharging for the dynamic loading. I also used a list again. So it was to emulate the dynamic loading, as I mentioned before. So because during real rover operations, the rover will not be continuously using the 460 watts, right? It's going to be very depending on the current demand that is needed at that time. So what I mean by that is, for example, in this column here, we have 30 amps and I kept it for 30 seconds. This is, for example, if the rover is drilling at the time. And then we have 25 amps at 20 if it's going up a steep slope. And even for like 6 amps here for 20 seconds if it needs, or if it's just doing cruise control, just going to the PSR itself. And then for the results of this, we can see the expected behavior of the dynamic load. So you can see that the slope varies depending on the current demand. And as you can see here, the higher the slope, the higher the current, the steeper the SOC goes down, and not so high, not so low current, not as steep, and then so on and so on and so on. And the BSS 2000 software also demonstrates that typical voltage behavior of the lithium-ion battery, right here shown in this pink line. We can see that it remains stable before experiencing that rapid drop as the SOC approaches zero. So throughout this test, we were able to see the behavior of the rover as it operates under varying loading demands, and that the battery can continuously provide a steady charge during such dynamic operations. So in conclusion, iTech products ITN 2121 and ITM 3432 provide accurate emulation and safe testing for rover operations without risking damage to the actual equipment. The SAS software provides customers with instant results without needing to physically wait for hours, days, or even weeks for the different irradiance levels. And the BSS 2000 provides customers with the same solution with faster results for battery behavior without needing to, again, physically wait for the battery to be charged and discharged to a certain percentage. Overall, iTech products provide realistic results and reliable testing solutions and showcase its effectiveness in the power electronics and testing fields. And that's the end of my presentation. Thank you guys so much for joining me here today. I really hope this was as informative to you all as it was for me when I did this project. If you have any questions, don't hesitate to reach out. And if you're curious about our products, check out our website, rexgear.com. I hope you all have an amazing day and stay tuned for more T-Rex Classroom. Bye-bye.
All right, let's give it up for Ro with some virtual applause. That was an amazing presentation. Right, we do have some questions that rolled in the chat over here, so I'll just go ahead and share them as they come. And again, please feel free to drop in more questions. So this first one we have, can the ITN 2100 series go past 800 watts?
ITN 2100 series can go back to 800 watts. It can go up to 1,500 watts.
Awesome. Next question we have is about the battery simulation software. So this person wants to know how many battery compositions are available in the BSS software.
So for our BSS software, we have three different types of software. So the base one has two. That one covers the lead acid and the lithium ion composition that I use for my testing. But if you want to be a little bit more advanced and have more chemical compositions, we have the Pro that has 8 tests. So it has the lead acid, the lithium ion. It also has nickel metal hydride and lithium ion phosphate, just to name a few. So there's up to 8.
Awesome, thank you. Right. Our next question is about the safety and protection features because some of these units can get very heated, so those would be important to have. So this person wants to know if there's any safety or protection features specifically for the ITM 3400 and the IT 6600C units.
Yeah. So these units, they pretty much have the standard protection features such as, overprotection, overcurrent protection, undercurrent protection, and then undervoltage protection and the overpower protection as well. So they have the standard ones.
Awesome, great. And then the next question, I believe you may have answered already in your presentation. They're wondering for the IT 6600C series, could you use one channel to emulate a battery and another channel to charge and discharge a battery?
Yes, you can. That's exactly what I did for my in-house testing. Since it's independent and dual channel, I was able to set one as my battery and the second channel to either charge or discharge it. It saved up on a lot of time and space, obviously, because it's just one unit in one.
Definitely. Ooh, the next question is a fun one. Why did you choose this topic?
Ooh.
Very open-ended.
Yeah, very open-ended, but honestly, I chose this topic because I really love space. Like, I think that's really, like, all there is to it. I love space. I love learning about space and then doing, like, especially with the recent Artemis 2 launch, I was like, whoa, this is really cool.
Were
So it
you
was
keeping
really
track of the launch, I assume?
Yes, I was. When they did their drop off or their landing, I think it was like a few days ago, yesterday. I had like an alarm set, so I made sure they didn't miss it. So that was cool to watch.
Yeah, it was pretty cool to see, especially since they landed pretty close to us in San Diego.
Yeah, it's so cool. I loved it.
Yeah. All right, we have a few more questions, so I'll just keep projecting them as they come in. How long did it take you to do this testing?
So to do this testing, it took me about 2 weeks. It was just because this was during like my training time, and this was like a application project. So I took it was most part of first part like learning the units itself and like making sure the setup was correct, and then after that it was pretty straightforward. So it took me about 2 weeks.
Awesome. Our next question is about the irritants. So what would happen if the rover enters the shadowed regions where no irritants is available?
So when the rover starts entering the shadow region, so it has two primary sources of powering itself. It has that solar array and the battery, right? So when it transitions into the darker side where there's no like sunlight available, that's when it starts using the battery's power.
I see. And our next question is about the maximum power. So what is the maximum power you can simulate as a battery?
That really just depends on your application. We do have a wide variety of products, so it's just very, very dependent on like how much, what you're working with.
Yeah, I know particularly for the IT 6600s, we have up to 42 kilowatts in 3U.
Yeah.
So that is very high power density that you could simulate.
Yeah, so if you have like a giant battery, then you can go feel free to use that one.
Yeah. We have one more question. What were some challenges you faced while using the iTech equipment?
Ooh, that's a good question. So this was again, as I mentioned before, this was during like my training period. So I was getting used to all of the equipment and learning how to program everything and learning like the list function and all that stuff. So one of the challenges for me to be honest, was honestly like, let me think about it. It was pretty much the list function. It was just weird to be honest, because it was like hard. It was again like learning everything, learning how to set it up properly. But again, I had so much support from my team and they led me through the process. And it was just something very silly because it was me forgetting to set it as like, oh, I have to discharge this. I have to discharge
I mean, hey,
it. So it
that
was
can
just,
happen sometimes.
yeah. So it was like something very small, and it happens to everybody. But I was able to get the support, and once I realized like, oh, I have to make sure that discharging for this test, and then after that, it was pretty fine. It was like very easy after that. So
Yeah, it's like a bit of a learning curve at the beginning, but once you get
yeah,
past that, smooth sailing from there.
yeah, exactly.
Okay, I think that was the last question. Oh, we have a comment that someone added. Thank you, Ruin Afreen. This was really interesting. I'm glad.
Thank
Hats off to Ro. That was an
you.
amazing presentation.
Thank you so much. I'm glad you guys were able to enjoy it. Honestly, this means a lot to me because I'm able to share what I learned from you guys, like share what I learned from during this project and also sharing the products that we have. It was honestly like such a joy to be able to work and like learn about these applications, especially like since it's something really new to me. So at the end of this project, I just learned so much and I'm like so happy that I was able to do everything.
Awesome. Yeah, that's really good to hear. I had a great time hosting you as well. And that brings us to the end of our questions. So thank you everyone so much for joining us today. Be on the lookout for more T-Rex Classroom series. We will continue to host more webinars with similar topics and more. So thank you all. And again, this recording will be shared with everyone that attended. So thank you and have a good day.
Thank you, everyone.